Today, I'm going to go into more detail on doing landscape queries with chemical sets. This is a sheet I was playing around with here, and you can see I've typed in several chemical names here in column C under chemical entity query, and I have just a blank here and therapeutic use here. The way the landscape sheet works is that these cells are the article counts retrieved from PubMed when a query with the column C values are appended to whatever is in row 3. So we have Ritalin or methylphenidate here and therapeutic use, and the number of articles that you should get back is 7,895. You can copy this and paste it into PubMed to verify that that's how many records you get back. Today, I'm going to do something a little more complex, a little bigger than this. I'm going to actually start using these columns over here for more information about chemicals. To do this, I'm going to go ahead and delete this and delete that. And I'm going to go over to the CompTox Chemicals dashboard, which is right here at comptox.epa.gov. And what I'm going to do for today is I'm going to download a set of chemicals. The dashboard has list of chemicals that you can get to by going to lists and lists of chemicals. These are just lists we've accumulated, the EPA has accumulated over years that have either go along with some publications or something like that. I'm going to find a small one just to make it easier and faster. So here's a set of antimicrobial ingredients and building materials, only 18. I'm going to go ahead and click on that name. That sends me over here where I can actually see the chemicals with their structures, the 18 chemicals in this list. But I want to download them, and one way to do that is to send them to the batch search. And then I'm going to choose Excel because I want them in Excel. And this gives me lots of things that you should take some time to look into if you're interested. But what I'm going to do is click on this abstract Sifter input file and then export that. What that gives you is a spreadsheet with 3 sheets. And I'm going to go over to the abstract Sifter sheet. And here are the chemicals. I'm going to go ahead and select them and copy and paste them on to the landscape sheet. What I have then is this identifier, the EPA identifier for the chemical. It's called the DTS-XID or DTS-TOX-ID, and these are hyperlinked to the dashboard. Then I have the preferred name, the EPA's preferred name for that chemical. Then the query over here is the preferred name plus the CAS-RN number. At this point, you can go ahead and add on any other synonyms you want to add on with an or between them. So this way I can build a large corpus of chemicals. I'm not going to build a really large corpus because that would just take a long time. And then you can go ahead and take a look at what you get. Let's put exposure here, something like that. And go get the results. The chemical names can often present a challenge for PubMed querying, partly because chemicals often have many synonyms. If you have a chemical name that you know is a mesh term, then you are picking up the occurrences of many of the synonyms. But sometimes it's better to go and actually put some of the synonyms in your query string. If you don't know what a mesh term is, it's a really good idea to go to PubMed and read about it. You can go here to PubMed and then do the help facility here. User guide, here it is, user guide right here. Read the user guide about mesh terms. This help facility or this advanced facility is a really great way to learn more about your queries. And the more you learn about making queries, the better queries you can write. Okay, so now you can see how to build different corpora of chemical names. I'm going to actually show you how to solve one of the problems that often occurs with chemical names. Here, I put this one here earlier on row 6. This chemical is interesting because if you look at it, you get lots and lots of articles, but I can tell you that this is wrong. And what I'm going to do here is I'm just going to leave this cell empty, and I'm going to put the word all here. So I'm not, the query I'm building is just the name of the chemical in the CAS. That's a lot. And I'm guessing when I look at this, and this is what you should be observant about, that there's an error here. So what I'm going to do is to check out whether there's an error with this chemical name. I'm going to double click right here, and this is just going to send it to PubMed. You could easily copy and paste it as well. And you can see immediately once you get to PubMed with this query that there's a problem here. It didn't find, first of all, it didn't find the CAS, and it didn't find this part of the chemical name. Well, the other part of the chemical name is the word fluoride, and there's lots of fluoride in the literature, so that's going to give you, that's why you've got such a high count. So let's look at the advanced tab and go down. So you can see what PubMed did with that query. It started expanding the fluoride term, because it could find the fluoride term, into all of these things, doing all these translations, and then it has a warning here that the main part of the chemical name was not found. So that's really an error. If you want information about this chemical, you're not going to get it. You're going to get lots of other stuff that might have this chemical in it, but probably doesn't. So what you can do to solve that problem is put quotation marks around it and put TIAB for title and abstract. This is one way to solve it. And you can see basically for this chemical, there really isn't any literature. So when you do get strange results, be sure to go to PubMed and look at the error message that PubMed gives you to see if you could not improve your queries. That's all for today. Thanks for dropping by.